This example will show you how to find the iterated integral of sine y over y of dy dx, x from 0 to pi, y from x to pi. This is the integral sine y over y dy dx, x from 0 to pi, y from x to pi. The first part is to sketch the region over which the iterated integral is defined. So let's sketch the region with the xy axis, x from 0 to pi, and y from x to pi. So suppose this is a line, y equal to x. So the value of y is from x onwards to pi. So this is y equal to x onwards to pi. So the region of integration is the upper triangle. X from 0 to pi, y greater than or equal to x less than pi. We are now going to evaluate the iterated integral by reversing the order integration. This is because when we try to do the integration, we find that we cannot integrate sine y over y with respect to y. Therefore, we have to reverse the order integration. That means that we are going to integrate sine y over y with respect to x and then y. Because of this reversal integral, we have to change the limit. So the outer limit is for y now. The value of y can be any value from 0 to pi. So we put down y can be any value from 0 to pi. And then the value of x, once you fix the value of y, the value of x will be x equal to 0 until x equal to y. So the limit for x will be x equal to 0 to x equal to y. Evaluate the integral. We start with the inner integral, which we have integration of sine y over y with respect to x, where sine y over y is treated as a constant. So the inner integral is sine y over y times x, where x from 0 to y. This is when we evaluate the inner integral. And this is equal to integration of y from 0 to pi. Substituting the limit, I get sine y over y times y minus 0, which will give you cancellation. This becomes the integration of sine y dy, where y from 0 to pi, which is equal to negative cosine y from 0 to pi. After integration, negative cosine pi minus negative cosine 0, which is equal to 1 minus 1, which is 2.